Yeah, long as it's
Alright. Today, we're going to start taking a look at...
Guys, Mr. Fach is talking. Sorry, I'm sure I'm crazy.
Yeah. Today, we are going to start taking a look at angle properties. We're going to take a few days here and look at the same idea that we were doing, okay? Just filling in blanks on proofs, but now we're going to look at stuff with angles. So on the front of this sheet, we're going to go through a few definitions, properties, and postulates, and then on the back, we're going to take some time to try to match those up, and make sure that we can recognize those properties. So first, all of these up here that we've already talked about still apply, okay? We're still going to look at equations where we can add, subtract, multiply, divide the same thing on both sides, okay? We can still substitute, okay? We can still use reflexive, symmetric, transitive, okay? All of things are still going to be used. We're going to look at a few new ideas down here, okay? The definition of congruence, this isn't a new idea. We looked at this for segments, but this also applies now to angles. The M of an angle symbol, that means measure. I talked about that a little bit before. Okay, with that little M in front means measure before, right? An angle bisector is just something that cuts an angle exactly in half. So, if we are told, and so you're going to want to write these down, and if we are told that we have an angle bisector, right, what we can conclude then is that the measures of two angles are equal. Right? So if I'm, let me draw a picture over here. If I'm told, say we got, and then I'm told that BD is a bisector, then we can conclude that the equals the measure of angle DBC. We've also talked about complementary and supplementary before. Right? If we're told that two angles are complementary, then I can say that those two angles add to 90. Right? So if I'm told they're complementary, we can conclude that those two angles have measures that add to 90. Right? So we would end up writing something like this. The measure of angle A plus the measure of angle B equals 90. Similar idea for supplementary. Right? If I'm told two angles are supplementary, then their measures add to 180. Right? So we can say the measure of angle A plus the measure of angle B equals 180 in this case. If I'm told that two lines are perpendicular, now remember we had a certain symbol for this. Okay, an upside down capital T, and whenever we see that symbol, that means perpendicular. So if I'm told that two lines are perpendicular, then they form right angles. Right? Well, then we can say if I have a right angle, then I know the measure of that angle is 90 degrees. Say, if I know angle A is a right angle, then the measure of angle A equals 90. Okay. So then the next one is a postulate, very similar to a postulate that we've already looked at. Right, we've looked at the segment addition postulate. Here, we're going to use the angle addition postulate. So, whenever we have a figure with multiple angles in it, right, we can say, well, this smaller angle plus this smaller angle will add up to equal the larger angle. Kodak, can you put your phone away for me, please? Oh, what is that then? Put your cards away for me, please. Thank you. So we can say This angle plus this angle equals the whole thing. So measure of ABD plus the measure of DBC equals the measure of angle ABC. We also looked at vertical angles, right? This is the one where if we have angles right across from each other, right? So when we have intersecting lines, right? If I've got angle 1 here and angle 2 here, I can say that those two angles are congruent to each other. And this is one where we would have to look at the figure, right? If I can look at the figure and recognize two angles that are right across from each other, then I can say those two angles are congruent. The complement and supplement theorem, a lot of times these ones tend to get confused with ones up above, okay, the definition of complementary and definition of supplementary. So complement theorem is saying if I know two angles form a right angle, okay, then they're complementary. So that's not quite the definition of complementary. Right? Definition of complementary is saying if they're complementary, then they add to 90. This one is saying if I know that they form a right angle, then they're complementary. So then we could use the definition of complementary as a next step to say if they're complementary, then they add to 90. Right? Similar idea for the supplement theorem. If I'm told that two angles form a linear pair, then they're supplementary. Then I could potentially, in a proof, use the next step to say, well, if they're supplementary, then the measures of their angles add to 180. Right. The last two on here are a little bit weird. Okay, the congruent supplements and congruent complements theorems. So what these are saying is if I have two angles that are complementary to the same angle, then they have to be congruent to each other. Right? If two angles are complementary to the same angle, then they have to be congruent to each other. So for example, if, let's say I have two angles, let's say this one's 60 degrees and this one's 30 degrees. Okay, they're complementary. They add to 90. Well, if I want another angle, so I don't know, let's say this is angle 1, this is angle 2, let's say I want some other angle down here, angle 3, that's complementary to this one. What would the measure of angle 3 have to be for it to be complementary to angle 2? What? 60, right? If I want these two angles to be complementary, their measures would have to add to 90. So if I take 90 minus 30, I would get that this angle has to be 60 degrees. Okay, that's what this theorem is saying. It's saying if two angles are complementary to the same angle, they have to be the same. Okay, in order for two angles to be complementary to the same angle, they would have to have the same measure. Similar idea for the congruent supplements theorem. If two angles are supplementary to the same angle, then they're congruent. Okay? So for example, if we've got two angles, I don't know, let's say 110 and 70, right? Plus, well, if I want some other angle, let's say this is angle 1, angle 2, if I want some angle 3 to be supplementary to this 70 degree angle, what would its measure have to be? So, yeah, this one would have to be 110, right? For those two to add to 180. So for two angles to be supplementary to the same angle, they have to be the same. So, I mean, we'll look at these when we have some proofs in the next couple of days, but these do show up on the back of the paper as well. Right? If two angles are complementary to the same angle, they're congruent, or if two angles are supplementary to the same angle, then they're congruent to each other. Okay? Any questions on any of these definitions or postulates or theorems? All right, then we're going to take some time here, flip over on the back, and try to identify which definition, postulate, or theorem, or property is occurring. All right, so we'll take 10 minutes or so here, and then we'll take a look at the answers.
Yeah, slide 4. Slide 3. I started slide 3. I just got to finish turning on my pictures.
I was going to put them on right now.
I think you all just
See.
because we're gonna do one pass.
Alright, so let's take a look up here. Okay, let's take a look up here. I believe these should be our answers, so let's go through these real quick here. Okay, the first one says, if angle A is a right angle, then its measure is 90 degrees. Right, so we're starting with it being a right angle. Therefore, it's 90. That's just the definition of a right angle. For number 2, we're saying if x is supplementary to y and x is supplementary to z. So both y and z are supplementary to the same angle. This should actually say that y is congruent to z. Does it say x is congruent to z on your paper? No, it's correct on your paper. It's just wrong on this paper. Alright? So that's the congruent supplements theorem, right? If two angles are supplementary to the same angle, then they're congruent to each other. And number 3, we're looking at the picture. Okay, number 3, we're looking at the picture, and we're saying these two angles are right across from each other. Right? If they're right across from each other, then they're congruent. That's just vertical angles theorem. Okay, if we can see that two angles are across from each other, they're the same. And number 4, if two angles add to 90, then those angles are complementary. That's the definition of complementary. For 5, we're saying if two angles form a right angle, then they're complementary. Okay, that was the complement theorem. Okay, that was the difference between definition of complementary and complement theorem. Right? If they form a right angle, then they're complementary. Is complement theorem. Number 6, if I'm told that two lines are perpendicular, okay, and remember we've got that little symbol here. Okay, that upside down capital T means perpendicular. Then angle 1 is a right angle. That's just our definition of perpendicular. For 7, if two angles are supplementary, then they add to 180. Our definition of supplementary. For 8, if we have two angles complementary to the same angle, so L is complementary to M and N is complementary to M, then L and N would have to be the same. They would have to be congruent. That's our congruent complement theorem. Number 9, if two angles form a linear pair, then they're supplementary. That's the supplement theorem. Number 10, if two angles are complementary, then their angles add to, or then the measures of those angles add to 90. That's the definition of complementary. Here, we're looking at the picture, right? For 11, and we're saying this angle plus this angle adds to equal the whole thing. Okay, that's angle addition postulate. If I'm adding this angle plus this angle to equal the whole thing. And then the last one, if the measures of two angles are equal, then the angles themselves are congruent. That's just definition of congruence. Okay? Any questions on these properties?